Hello and welcome to the Headlamp Report. I'm your host, Mark Singer. I create videos that focus on SpaceX's Starship program, with a particular emphasis on trying to assess just how likely it is that SpaceX will achieve the goals of sending a cargo mission to Mars in 2024 and a manned mission in 2026. I look at the Starship program as a whole from a project management point of view, and starting from the presumption that the 2024 and 2026 goals are achievable, then by working backwards I've created a plan with milestones and timelines, each of which I believe are realistic and achievable. And as far as I know, the Headlamp Report is the only channel that looks at the Starship in this way. It covers the initial cargo and manned missions only. I don't look at rapid reusability or large scaling up production, because these appear to me to be primarily milestones on the critical path for SpaceX's much longer term ambition of Mars colonisation. I make these plans accessible to all fans of Starship so that we can discuss all the points. Do you agree with my milestones, my timelines and my assessments of likelihood? Please do comment and let me know. And if you want to see more content like this, please like and subscribe to my channel. The next episode of the Headlamp Report follows in a moment. Hi there. Most of the video that follows was recorded before the announcement that NASA had awarded SpaceX the contract for the human landing system part of the Artemis project to return humans to the moon. The awarding of this contract could have a significant impact on SpaceX's plans to go to Mars, and therefore on my own project plan interpretation of those goals. It remains to be seen whether SpaceX will now adopt a single track plan of Moon then Mars, or a twin track plan of Moon and Mars contemporaneously. I think I know what Elon's preference will be, so for now I'm just going to stick with my plan as it is. Please do drop me a comment and let me know what you think. As you can see, I've had my hair cut for the first time in many months, so I'm ready and raring to go. Today I want to share with you my updated Starship project plan. Remember, this is my plan, not SpaceX's. I don't have visibility of their actual plan. Nevertheless, the milestones I've included do represent real targets that SpaceX must achieve with Starship in order to get to their overall goals. The content of today's video is shown here. Milestones and sub-milestones are the building blocks of my plan. I focus on the critical path. As the Starship project encounters successes and experiences delays, I'll re-evaluate my milestones and sub-milestones, likelihoods, timelines, risks, etc. I'm not going to talk about risks today, as these are not really changed from my previous videos. The challenge is to keep this simple while also insightful. At the end of today's video is a summary of my current expectations and predictions. You can skip ahead to see this by using the chapter headings in the description, or if you want to really understand why I make the predictions I do, please stay with me so that you can see how I've built this up through the different milestones and timelines. I really welcome your comments on these. As always on my channel, there's a slide pack that accompanies today's video, and the link to this is in the description. I've changed and updated some of my project terminology for consistency and to avoid confusion. So let's start there. Milestones are goals that SpaceX must achieve, and they're divided into smaller, discrete goals called sub-milestones. There are 5 milestones in my plan that comprise the critical path for achieving first a cargo mission and then a crew mission. These remain the critical path milestones even if the eventual launch dates change. I've categorised them into 2 types. First, there's the performance milestone. This relates to critical technologies, and the sub-milestones for this relates to proving capability and then reliability. Second, there's the readiness milestone, which encompasses everything else SpaceX needs to be able to do in order to be able to arrange and organise a mission to Mars, once performance milestones have been achieved. I've also created various informal plan review points. These aren't SpaceX milestones, they're simply markers for me, and they're not set in stone. Feasibility reviews consider whether there exists a reasonable expectation that capability can be achieved by the relevant sub-milestone end date. As an example, I considered that SN10 demonstrated a landing capability, so you'll see that this sub-milestone is marked as complete. Feasibility leads to capability, which leads to reliability. The first milestone, and in my opinion the most difficult for SpaceX to achieve, is putting Starship into low Earth orbit. The likelihood of success by this due date is derived from its sub-milestones. So let's drill down into these. There are 4 sub-milestones, each with its own timeline, due date for completion and likelihood of success. Remember, these are my guesstimates. The product of these likelihoods is 41.55%. Since we have a fairly good idea of how SpaceX intends to achieve low Earth orbit, each of these sub-milestones is divided into further sub-milestones. So let's drill down into each of these 4 in turn, starting with sub-milestone 1.1, ground support infrastructure. Please note, timeline finish dates of any sub-milestone is determined by whether the next milestone, which is dependent on it, can begin. These 2 sub-milestones represent orbital and suborbital infrastructures with their associated ground support systems. Cumulative likelihood is 90%. I want to show you some timeline charts, and let's start with these sub-milestones. 1.1.2 orbital launch mount has a finish date of 30th of June 2021. This means that enough of this sort of ground support equipment systems have been completed so that super heavy booster testing can start, which we'll see in a moment. Now let's look at the sub-milestones for 1.2 Starship performance. As I said earlier, performance is capability followed by reliability. So here we have the 2 sub-milestones which represent those aspects for Starship under its own power. Again, cumulative likelihood is 90%. As I mentioned previously, I marked 1.2.1 as complete after SN10, which is why it shows 100%. But 1.2.2 has a long way to go, and I want to talk more about this shortly. Adding these milestone timelines to the ground support milestones on which they depend shows a new chart here. I've added 3 feasibility review dates for assessing Starship progress and a capability go, no-go review. These assume that SpaceX make consistent progress. Hopefully these scheduled reviews will in due course match project status fairly closely, but I can always change them. Moving on to the Super Heavy booster. Here we have similar sub-milestones for capability and reliability. Cumulative likelihood here is 72%. And like the Starship milestones, 1.3.1 is considerably easier than 1.3.2. Adding these milestones and the ground support milestones on which they depend to the timeline chart shows like this. So far, none of these milestones involve any orbital capability. That comes in the final section of low Earth orbit milestones 1.4. So this is the sub-milestones for a stacked Starship vehicle. Again, 2 sub-milestones, one for capability and one for reliability. These sub-milestones include my prediction for a first successful orbital flight in the second half of 2022. Having achieved a certain level of reliability for the Starship and for the booster separately, then achieving reliability for the stacked vehicle should not be quite so difficult. I anticipate a certain amount of crossover between these different reliability milestones, but for now I have them separate and with a cumulative likelihood of 71.25%. I've added these sub-milestones to their timeline chart here. What this chart is saying is that Starship and its booster must have orbital reliability before the Mars cargo mission can be considered to have attained capability. So we need to think more about reliability, and that's coming up in the next part of this video in just a few moments. In a previous video, I posed what I consider to be the big question, and that is, how many consecutive test flights can a Starship undertake on the same set of Raptor engines? And I proposed that for a cargo mission to Mars that should be at least 2, and for a manned mission at least 3. Now I don't expect SpaceX to pursue this goal directly during testing, because it would inevitably result in more rapid unscheduled disassemblies. So I think they will protect their Starship prototypes, and after every successful landing they'll do an inspection and they'll swap out Raptor engines as they deem fit. But because of this, I expect that they will refly prototype Starships as many times as they can and as quickly as they can in order to drive the reliability data that they'll need. While pondering this question of reliability, I came to what I think is a deeper insight into the whole Starship program. So consider all the engineering challenges that SpaceX have with the Starship. So the pressurization problem, the landing problem, the fuel transfer problem, the radiation protection problem, and the in-situ resource utilisation problem, to name just a few. Now these are difficult challenges, to be sure, but I'm confident that SpaceX will find more or less elegant solutions. By elegant I mean effective in terms of the engineering and efficient in terms of the additional weight cost to the Starship vehicle. Maybe they won't achieve all these by 2024, but likely by 2026. Why am I confident that SpaceX will solve these? Well, that's because I look at these as normal engineering problems. Perhaps not in a normal engineering context, but nevertheless normal problems. But there is one aspect of the Starship program which is decidedly not normal. That's because it is a very new technology, and it's the one thing on which the whole of the Starship program and SpaceX's ultimate Mars goals depends, and that's the Raptor engine. SpaceX's full-flow stage combustion cycle rocket engine is the most advanced of any rocket engine manufacturer today. Its advantages are in terms of thrust and efficiency, but its disadvantages are in terms of its complexity and newness. There are two variants, a sea level optimised and a vacuum optimised variant. But until SpaceX started testing in summer of 2019, no Raptor engine had ever flown. Even today, no Raptor engine has flown twice, and still vacuum Raptors have yet to fly. Both these variants need to attain certain levels of reliability in order for a crew Starship to be certified to carry passengers. But what is this measure of reliability? Now, SpaceX have not given us any clues as to what measure or measures they'll use. But NASA, in its commercial crew program, stipulated that risk of loss on ascent or descent should be no more than 1 in 500, and risk of loss of the mission overall no more than 1 in 270. Now, it's not clear that the Raptor engines will ever reach these tough criteria. For a cargo mission, you don't need quite such strict criteria because obviously there are no people on board. But with a manned mission potentially only 2 years away from a cargo mission, then you would hope by 2024 SpaceX would be getting near to a level of reliability for their Raptor engines that would support crew certification. Now, what about dearMoon, I hear you say, which has been announced as launching in 2023, and I want to talk a little bit more later in this video about dearMoon and also about reliability in a little bit more detail. But up next, I want to take you through the critical path milestones 2 and 3, which take the cargo mission to a state of readiness. The second critical path milestone is in-orbit refilling, which means filling liquid methane and liquid oxygen tanks of one Starship from another whilst in low Earth orbit. The Starship uses most of its fuel simply getting to orbit even after the lift from the super heavy stage. Technically, methane is propellant and oxygen is the oxidizer, but I'm going to refer to them both simply as fuel for the purpose of this milestone. Likelihood is 48.7%, and cumulatively for the first and second milestone together has now reduced to 20.2%. Let's look at how the 48.7 is arrived at. So this has two sub-milestones, 2.1 and 2.2. First, SpaceX need to put a tanker version of Starship in orbit. A tanker version of Starship will have larger tanks or more tanks compared with the vanilla prototype Starship, and so will have more fuel on board when it reaches orbit. Then that needs to dock, transfer fuel and undock with another Starship. 2.2, being a technical performance milestone, has its own set of sub-milestones. First, SpaceX must demonstrate a capability to transfer fuel in orbit. Second, they must demonstrate a capability to carry out multiple fuel transfers. And finally, they must demonstrate reliability. Once starships of various flavours can be reliably delivered to orbit and fuel transferred, then SpaceX really are in a position to go to Mars. If this can be achieved by the end of Q3 2023, 12 months before the 2024 launch window opens, then it's on. Get that cargo mission prepped. Which brings us to the third critical milestone, cargo mission readiness. At 42.75%, the cumulative likelihood for the three milestones is now 8.6%. There are three sub-milestones. First, SpaceX must put a cargo version of Starship in orbit. Second, rehearsal missions have to be undertaken to finalise the Mars cargo mission parameters, as well as potentially being part of a crew certification process. Finally, it'll be necessary to bring all the mission elements together in the right place at the right time. Let's speculate for a moment on what these rehearsal missions might look like. You may have seen cargo Starship renders showing a clam-like opening of the nose cone. This design would likely work well for putting Starlink satellites in orbit. There is a huge financial incentive for SpaceX to use cargo Starship for Starlink deployments, because a Starship should be able to deploy anywhere up to 400 of these satellites at a time, instead of the 60 with Falcon 9 at present. So I will think this type of cargo Starship put into service pretty quickly. But a clamshell design does not seem ideal for transferring cargo to the surface of Mars. I think SpaceX will go for a different design, perhaps with a side opening like some kind of space Winnebago, plus a lowering mechanism. I've therefore created two sub-milestones, 3.21 and 3.22, as shown here, for clam and non-clam cargo Starships. These milestones are still some way off, and it's hard to predict how SpaceX will manage this part of the programme, so I've guesstimated the likelihood for 3.2 as a whole to be 50%. These milestones complete the cargo mission critical path a few months before the opening of the launch window in September 2024, if all goes according to my plan. I want to share with you a forecast for Starship test flights, beginning with SN15, that I've created as a way of getting this important conversation about reliability started. The numbers you'll see do not include super heavy booster test flights. A flight is only deemed successful if the Starship can be put back on the launch pad or back on the booster after its flight has completed. Raptor engine swap outs do not invalidate the success of a test flight in these scenarios. This data set envisages 75 Starship flights by the end of 2023 and sets success criteria for capability and reliability go, no-go decisions. You will see that I envisage just 2 flights in Q2 2021, increasing gradually after that. Because the SN11 anomaly was much more significant than with SN10, I'm going back to my previous rule of thumb of 5 weeks between test flights of Starship prototypes when there is a safety investigation. In other words, my prediction is that SN15 will not fly in April because of delays in obtaining a launch licence from the FAA. There is another data set for the period from January 2024 which we'll look at in a few moments. Remember, this testing schedule is entirely my own invention. It's an attempt to create a yardstick to measure real launches, but what do you think of my figures? Elon has said there will be many flights before 2023. Do you think this will amount to more or less than 75? More than 75 flights is not totally out of the question. Indeed, more might be necessary if the rate of unsuccessful flights is higher than that shown here, which is 5.3% unsuccessful flights over the period. One flight every 10 days between 1st of May 2021 and 31st of December 2023 equates to about 97 flights. The reliability threshold for a cargo mission can be set somewhat lower than for a crewed mission for obvious reasons, but probably not by all that much. It would be a huge blow if a 2026 crew mission had to be postponed to the next launch window in 2029, only because the Starships launched in the 2024 launch window crashed on arrival at Mars. To mitigate this risk, and depending on the level of reliability attained at the time, SpaceX might look to some redundancy as regards Starships and payloads for the 2024 cargo mission. For example, sending 4 Starships, 2 with identical ISRU payloads and 2 with identical habitat and crew supplies. Coming up next, the crew certification or human rating milestone. The human rating for Starship's milestone is very preliminary, so I've just given the whole lot a 50% or 1 in 2 chance. And there are 2 sub-milestones because I envisage 2 separate certifications, one for a short duration space mission and one for a long duration. Ultimately, it may be that all Starships get a long duration space mission specification, but in the short term I suspect there will be the 2. The main difference, of course, will be the extent of the radiation protection that will be necessary on a long duration space mission to protect the crew. If 4.1 is not achieved until the end of March 2025, what does that mean for the dearMoon mission announced for 2023? I'm going to discuss that in just a moment. dearMoon is a private lunar tourism spaceflight conceived and funded by Japanese billionaire Yusaku Maezawa. In it, the space tourists will fly a Starship on a single circumlunar trajectory on a mission lasting about 6 days. And it was recently announced that this would launch in 2023, Elon saying that by then Starship would have flown many times, including to orbit, and that it would be safe to carry people. For the purpose of this discussion, I'm going to assume that dearMoon is a fully Starship venture, because this aligns better with SpaceX's ultimate Mars goals. Other permutations have been suggested involving Falcon 9, Crew Dragon and Starship, but with NASA awarding SpaceX the Human Landing System, HLS, contract, I think these other possible scenarios look unlikely. The impact HLS might have on the project plan for Mars and the 2024 and 2026 goals in particular I'm going to look at in a future video. How feasible is 2023 for dearMoon? To get to that level of reliability will indeed involve many flights, successful flights, orbital flights, but to get to that state from where we are now, which is still with pieces of SN11 lying on the ground in Texas, just seems too big a stretch. So I'm calling dearMoon 2023 no-go. You can't rush crew certification. NASA awarded SpaceX the Commercial Crew Program contract in September of 2014, and they only certified Falcon 9 and Crew Dragon as crew rated in November of 2020. Now, for a private space flight, you don't need NASA to certify the craft. Nevertheless, with this new tie-up between NASA and SpaceX, I think SpaceX will be under a lot of pressure to follow NASA's playbook when it comes to human rating of a spacecraft. JS Space Report, a recent video by To the Future, argued that dearMoon would slip to 2025, and this was recorded before the award of the HLS announcement, but I agree with the 2025 date. Because if you look at the milestones in my project plan, and now especially with HLS as well, I think SpaceX is simply going to be too busy to prioritise a crew-rated Starship for dearMoon in 2023 or 2024. And for that reason, I expect dearMoon to launch no earlier than Q2 2025. Coming up next, the final plan updates for this video. Let's have a look at the final milestone for crew mission readiness. If SpaceX succeed in launching the cargo mission in 2024, then even if Mars arrival goes badly, I expect them to push ahead with crew certification and crew rehearsal missions, leaving open the possibility of sending crew and cargo in 2026. Crew mission rehearsals are my final critical milestone. I've split rehearsal missions into two, with and without landers. For example, dearMoon is a non-lander mission, but it would still contribute to crew mission rehearsal data. Rolling up these final sub-milestone timelines give us a final timeline chart. Although attempting both crew and cargo at the same time would be a very high-risk strategy, reliability of Starships and Raptors by 2026 might make it an acceptable option. And we're back to the question of reliability. So here is that additional reliability flight forecast data set I mentioned earlier. As you can see, this additional data set envisages another 120 Starship flights between the beginning of 2024 and the first half of 2026. That's a rate of 12 per quarter, or just less than one a week. This doesn't include any Mars cargo mission launch. How optimistic do you think this flight data set is? What do you think about the failure rate? Only one failure in 120 flights? But if Starship is to be certified for human flight, then a failure rate of less than 1% would seem to be a prerequisite. And finally, here is a summary of all my expectations and predictions.